All right, well, thanks everyone for joining. This is Joe here. Again, very excited to have you guys here today. We are going to be going over, kind of as Matt said, a bit of the lathe probing that just got released in Cimco Probing, as well as some of the Mastercam integration and also the MDC Max, a little bit of the kind of more of the advanced features on the emailing side, and a lot of that there here. So we'll jump right in here, guys. So kind of have a little bit of a slide here just to kind of prep you guys beforehand. So we are working with the Cimco Lathe Probing. It is to be noted that it is the beta version currently. So if your CNC does support lathe probing, then you can always reach out to us to see if we currently support your machine or what the timeline looks like for getting that supported. Some of the main features are going to be a lot of what the Simco mill probing is going to be supported here. It's going to be a lot of the in-process checking, setting any work offsets, and remachining. So I have a couple examples ready for you guys. So I'll go ahead and switch that over. This is actually going to be this file. Okay, so let me minimize this out. All right. So as you can see, I've got a mill part pulled up into my Mastercam window here. In the features that we're going to be looking at, we have a bit of this kind of keyway here. So what we'll be able to do in the Simco probing side of things is actually go into the window, and if your post supports it here, then you'll have some of these options available to you. So just as a quick overview before we get into the meat of everything, we do have some alignment options on the C-axis here if we wanted to kind of clock that in, both on the horizontal and the vertical side of things. If we're setting any work offsets with the probe, we can always do that as well. We've got width inside, outside, a few of the angled widths, some of the rectangular features that may be on your model, as well as any board or bosses inside of here. Same goes for the horizontal side here. And then mainly all of the cycles that we're going to be seeing are going to be available in the inspection side. So whether we're setting any work offsets with the datum, or if we're doing any in-process checking with the inspection side, you'll have all these options available to you. So I will get into a quick example here. So I'm going to go ahead, and this is going to be a spot drill operation, then actually a hole after that here, getting this out before it gets tapped. So let's say you'd like to use your probe to see what this diameter of this feature would be. I can go into the inspection side of things on the Simco probing, and I can go into diameter inside either 3-point or 4-point. So what the Simco probing window will open up here, and you'll be able to select your probe out of the list here. You'll also be able to go and do the tool manager and pick which probe if you have multiple defined in a library here. So after the probe's selected, I can then go into my cycle tab. I can right click inside of this window after I turn my automatic tool plane selection on. And I'll make sure that actually I am in the bottom side, I believe. If I select an arc, I can then see that being previewed in the window here. So my diameter is at 201 number 7 drill. Inside the list, I can then up my measuring height, and I can adjust how far down into that hole I'm going to be going as well. And then your tool path is actually previewed on the window. So what I can do in here is I can actually just scroll my mouse wheel if I need to adjust anything. You can see the toolpath output changes on the screen. So the main question now at this point is, what do I do with this information after I've probed it? So what I can do inside the Simco probing side of things is go into this measurement results section, and I can choose actual diameter. And on this particular postability Akuma post, it's going to be writing off to, that common variable section here. So At this point, we've probed that hole, and we can have the operator go ahead and check that VC52 parameter there. If we do this a quick back plot, you can see my tool is displayed on the screen. And that's going to go ahead and back plot that out for us. So just like that, you've got your hole diameter written off to that VC52 variable. What you can typically do here as well is you can go into some of your mill paths, and I would do typically like a manual entry here. And you could say M0 and then have the operator check VC52 for diameter. So that way, when this gets posted out, the operator can then go check that right off the bat and make sure that this is all good before we continue on with the operations here. So outside of that, we've got a whole bunch of different options here available to us. Actually, get back into top view. So let's say I've machined this part out here. Looks like we've got a little bit of a peel mill here that gets some of that material out. Potentially after this op, let's see maybe if I wanted to check the width of these two features here. So I can go into the Cimco Probing. Same thing on the inspection side, I can do a width inside. Select my probe just like we did before. And I can right click, select two lines, which is going to be this edge and this edge here. We'll automatically select that plane here. And you can see once I adjust my clearance height, I'm able to see the output of that path. You can also throw in a safety distance. Let's say if there's a boss in between that feature, potentially, I can go in and wrap it above to avoid anything. Same thing with that. If I'd like to do any measurement results, I can output that to a variable on the control. You can also use any remachining inside of this as well. So with the remachining and Simco probing, if you're not familiar with it, we do offer three options for that. One's going to be what happens if the part's scrapped, if that file or if that dimension's too big. So if it's scrapped, let's say, no reason really going around with it. Let's just, go to program end here. Now, if we're remachining, I can go to a particular operation in the file after adjusting the tool offset. So in my toolpaths window, that peel mill was operation 6. So I can go into this peel mill after adjusting the tool offset, which we can throw into this value here. Or if we're within tolerance, if we specify a remachining tolerance inside of here, we can then continue on with the program. So it makes it very simple for the operator to kind of have no input into a lot of this and actually just use the software to remachine a lot of these parts here. So there are optional parameters like we saw inside of here as well. So we'll cover these a little bit more. So if you're actually trying to get some of the data out, you can use this W parameter inside of here to print some of this data off. You can either increment the feature number or increment it and reset. That's going to change that W value inside of here. We mentioned that this is the tool offset number that's going to be updated. So we make sure that that matches what we are trying to update. Dimension tolerance, you can see here, that's going to be the bilateral tolerance of the feature. Experience value is the number of the spare tool offset where adjustment value is to be stored. And we've got some true position tolerancing, upper limit tolerancing, and then that adjustment zone. It's going to be like your null band value here. So that's going to be percentage value. Upper tolerance, so if that's exceeded inside of here, then that's going to actually alarm that machine out, and then nothing's going to be updated for us. And then true position is going to be kind of a theoretical position here as well. So you can use all of these optional parameters inside of the window to kind of get exactly what you're trying to do inside of the window here, especially for this the remachining side of things. All these taken into consideration there. So this is going to work just like Mastercam. If we change anything inside of the operation, it's going to go dirty on us, so we can always just regenerate and go on to the next path here. So I can also do a quick, let's say if I wanted to measure what the Z height is on this face, I can possibly put a point right on that face. And then at this point, I can then go into inspection and then do maybe like a 0.1 axis here. If I right click, select a point. So the clearance height, we're going to have to adjust that inside of here. We want to make sure that the plane is selected as well correctly. It's going to be bottom, I believe. Yeah, and then the safety distance is how far we're going to be feeding into that feature. Clearance height is going to be the rapid distance until we start to feed. At that point, you could say, okay, backplot some of that out. That's going to touch that off here. And like we did on the hole measurement here, you can also write that value off to a variable on the control. So VC53 will write that off to that variable. And we can do something similar with the manual entry that we selected beforehand. All right, so I do have another model that we can kind of go over a couple different more features here. I just edited the solid itself. So let me turn this guy off here. Okay. Should be right view. Okay, perfect. So inside of this model, I just kind of drew a boss inside of this feature here. And we can look at some examples on how we would measure something like that. So I can go in and I could say inspection. You can actually do a rectangle inside of this. So this will allow us to go into that cycle section, select a chain. And we want to make sure that this is going to be the correct tool plane. So the clearance height, we make sure that that's above the part, away of any potential crashes or anything like that. And then we can get into it and see what that toolpath looks like inside of here. So maybe like, let's say 1.1 for this. And you can see the output that's on the screen. Same thing like we did before, you can output any of this data out to variables on control, whether that be the width or the height here. So just like that, you know, within a few clicks, you can get a probing cycle generated fairly quickly here. Now on the horizontal side of things, if your probe is into that part of the spindle, you can actually go into that view. And let's say if you wanted to measure what this bore was in the model, I can go into that inspection side and I can do, let's say, a diameter inside 4-point or 3-point. I can then select an arc on the model. Just my clearance height. Just this, it's going to be our measuring height here. Safety distance is going to allow us to wrap it above. You shouldn't need that for this model, but that's an example here. So once that's all set, you can say okay, and we can backplot that out and see what that looks like here. So very straightforward stuff. A lot of the Cimco Lathe Probing is going to be exactly what you're used to in the Mastercam mill probing on the Simco side. So it should be familiar if you are a current user, but fairly quickly, fairly able to quick. Excuse me. You're able to fairly quick. to pick it up fairly quickly here. Excuse me. Sorry about that. All right, so yeah, if there's any questions on if your machine is supported, you can always reach out to us on that front. Like we said, it is in the beta version of the software, so we are still checking on machines functionality inside of everything. So please get in touch with us and we can kind of determine whether you're supported or not. So I will save this one out here and we'll get into our next example. And that's going to be on the Simco Edit integration with Mastercam. So if you're a Simco Edit professional user, you're probably familiar with the backplot feature. So this will allow you to backplot out G-code rather than just using the NCI in Mastercam. So we have come out with some integration with Mastercam to use that backplotter or the machine simulation as well. So you'll be able to bring in any fixturing, any stock, any work pieces direct into the Simco editor when we backplot, rather than building that stuff up by hand, essentially. So we've got a example of that here. So in this model, I've got some for this first operation for any of this prep side of things. We actually have some stock model defined. So once we install the Simco Edit integration here, it's going to create a tab up top, run Simco Edit. If we click on that, you can see your machine types inside of Simco Edit, whether you want to backplot by default or if you want to launch your machine simulation, you can do either. And inside of here is where we select some of the geometry in the window. So for this workpiece, I can say select. And in my, actually, let me go ahead and turn off the stock model here. So the workpiece, I could say select and choose my tool body here. The fixturing, I could say select and then choose any of my fixturing in this part. And then the stock model, I can either use my stock setup, an external STL, something that's on a level in Mastercam, or a stock model. So I have this stock already set up here for that squared stock. And what I can do is, once those are all set, I can choose all of my operations I'd want to launch. And then once those are all selected, it's going to trigger a posting out of all those operations. And since we selected all this geometry, it's going to launch our backplot window. And you'll be able to see this inside of the window direct into the editor. So if we go through, you can see that it actually is pulling your tools into it here as well. So that's pulling that spot drill. Looks like this is going to be our next drilling operation. I'll speed this up just a little bit here. He looks pouring out and then doing some dynamic milling. And you can see the stock is being taken away on the model itself as well. So if you notice, you do have some collision checking on the shank and on any of the parts of the tool that may cause a crash inside of there. So inside the tool manager in the Simco editor, we go to our backplot side of things and we go to tool setup. You can edit some of the dimensions of your tools if they don't come in exactly correctly from Mastercam here. So I can say, right click, edit some of these things, and I can edit a flute length or shank diameter, anything like that that comes in a little bit off, because it is kind of automated from the C-hook here. So essentially what you'll be able to do is this is actually just a tool that you can use alongside of the Simco editor. It's currently not licensed. You only need the Simco Edit Professional license to run this. It's just installed directly on top of Mastercam. So if you have any questions on this, or we can kind of get you going on trying to get using some of these things, then we can certainly hop on here. So give us a call and we can get this set up if you are a Cimco Edit user. Okay, well, I'll go ahead and save this out. And we'll hop into the next portion of the demonstration here, which is going to be the advanced reporting and advanced features of MDC Max inside of here. So let me close out Mastercam and we can jump in. So if you are or potentially ever looking into using the any MDC system, we all know that reporting is a big part of it. We want to make sure that people in the organization have an idea of what's happening on the machine, not having to pull some of that data manually. With some of the kind of more advanced features in MDC Max, we can automate a lot of these things. So let me close this out here. I will hop into my virtual machine. Okay. So I've got a couple of machines that I've set up to run some of these things here. You can see I've got a Fanuc 31i and a Mazak control. So you can see right now that my Mazak port is in a state of no work. So what that means is there's no job or part number or anything really running on that machine at this point. So what Simco is really great at is actually tying into additional features and additional software packages in the background. So let's say if you enter this information for this machine in your ERP system, we can pull this information direct from that database. So I've got just a sample kind of example for this here. So for this Mazak smooth control, these would be essentially different fields inside of my database. So I'll be able to pull in my production or ID. I'll be able to pull in the employee ID, any part numbers, op time, things like that. So how this works is we actually tie in direct to that database through our external IO feature. So you'll be able to pull in the machine and select this data from that table and then put that right into the MDC side of things. So the way we do that is we can actually do a stored procedure inside the database, or you can actually have the operator pull that directly. So I have a button in my operator screen called ERP information pull. If I hit that button, it's going to grab all the data that I tell it to, essentially for the work order, for the part number, who's running the machine, expected time, and then the sequence of the op potentially here. So once that's done, the machine can then start running. And let's say I'm in an active state. Machine's running well here. So some of that can be directly automated with your system. So a lot of this is for, let's say we're trying to reduce operator input in some of these systems here. So instead of having to type it into the ERP and then type it into the operator screen here in our work order information, we can use the linkage to that system to pull that information directly. So outside of the ERP integration, we do have some automation on some emails as well. So what I can do is outside of the operator screen, let's say my machine stops here. And then for some reason, something happens on the control and I get an emergency stop. So what I can do in MDC is I've set up some alerts inside the system to when this e-stop timer hits 30 seconds, it's actually going to send me an email. So once that's all taken care of, let me go this here, go back into MDC Max. So I will look at, maybe my email here. Let me up out of here, and it should be sending me an email just about now. So at this point, we have a Mazak alarm, saying that e-stop has been running for 30 seconds or longer. So this provides you some opportunities to kind of automate that process here. So the opportunities are really endless with this. You can set up multiple different alerts inside of here in the email section. So I just have this one, but how we do that is, we format what the message is, any variables that we want to use in the system, and then when this trigger happens is when that email gets sent off. So when that e-stop timer hits 30 seconds for this machine, Mazak SmoothX, it's going to send this off to my email here. So very straightforward in how we set that kind of thing up. Excuse me. So I'll take that out of e-stop just to reset that timer. All right. So we can also do things in MDC Max on the reporting side of things as well, which we all know that that's a very important part of things as well. If you're unfamiliar with how MDC Max works, is we have the tables and charts, which are essentially graphs and tables that we can formulate inside of here. And then on the reporting side of things, those are going to be a kind of a combination of all those reports. So for instance, if I generated a report manually, I can do that from today. And this is going to open up in my browser or in whatever PDF you're using. And you'll be able to see what the timeline looks like for what's happening on the machines. So these are going to be all my downtime codes here. You can actually get a utilization on your machines as well. So this Fanuc 31i has been running a bit over 50% today. Mazak's not been used quite a bit, only 6% here. And you can get a downtime as a percentage of what your shift looks like as well. And then some graphics on what your utilization looks like. So instead of having to manually do that, let's say at the end of the day, let's say I wanted to maybe schedule a task to do that. So in MDC Max, what we can do is actually work with the command line side of things. So inside, you can actually schedule a task within Windows to use the MDC Max side of things here. And if we have reports set up inside of here, it's going to send off this report to whoever's in a list of emails that we send off here. So if I know this is the scheduled task, but I can always just run this here. You can see that that daily report is being sent off to me here now. So we can then get this emailed off direct to us as well. So let's say at the end of the week or something like that, if you want to get a gauge of how your machine was running all week, or maybe even at the end of the day every day, we can send off this information directly with some of these automation features here. I'll minimize this out. Now, that's on the automation side of things. We can actually use some of the database tables, the real-time database tables inside of MDC to really coordinate and customize exactly what you want to pull from your data that gets sent back to the server. So what I mean by that is inside of here, we have these things, like I said, called real-time database tables. And for this particular table inside of here, I can specify what I want to pull when certain messages come into the system. So for this particular one, I am kind of pulling the job, I'm pulling the part number, the state of what downtime state it is, the duration of the setup, material inspection, tooling, really any of the downtime timers that I want inside of here. So inside of our data section, I can go into that database view. And inside of here, I can choose a date. Let's say I wanted to do a couple days ago here. So if I search for this, it'll actually give me the machine name and what type of downtime was available or was happening on that machine, the current job, the current operator that's running that. And what we can do is actually export this off to Excel. So let me go ahead and click that here. Now, inside of Excel, you can actually format a lot of these things. So what I'm using is a template inside of Excel to kind of make the data look nice. And then on the bottom here, I can actually get a complete sum of all the job downtime here. So for this particular day, what we pulled on the job, it's actually going to be, kind of accumulating all the setup here and all the different downtimes that do happen. So for the Mazak Smooth X control, looks like we had, quite a bit of downtime for that day. This is all automated for you. You're not really having to pull any of this manually from your system.
We do have one question on this, Joe.
Sure.
When I generate the report, I don't receive any data.
That could be on some of the configuration side of things. We can certainly take a look here. Is it John Hansen's question here?
No, I'm answering his now, but
Okay, for Darcy.
Darcy.
Okay. Yeah, Darcy, we can certainly look at that. I'm not sure what we're trying to pull for a lot of this, but we could take a look for sure. A lot of the reports are set up. Like we said, the reports are going to be a combination of your tables and graphs here. So really how we set up the tables graphs is in this section here. So there might be something that needs to be configured a little bit differently. We can set up a time with you afterwards, Darcy, and we can take a look. Yeah, I'm not sure if any of you guys are really interested in the data collection side or getting a better idea of kind of what your machines are doing here, but I do appreciate you guys all coming and spending some time with us here to take a look at some of this stuff here. If you want to have a conversation with us regarding any of these things, whether it be the lathe probing, editor integration, or the data collection, you can always reach out. Number is going to be 888-222-7126, and you can always email us here as well. So thanks very much, guys. I appreciate you all taking the time today.
Thanks, everybody.